Hello, this is Akem Salahuddin, ID 17301201. Today I'm going to present our line follower robot. And first, I want to talk about how we build the robot and how we build the environment and how we build the line to get the robot started. So first, we made a robot which follows a certain line, and then we added the wheels and other necessary objects, and then we created an environment for the robot. And for this, we started certain criteria from here. Like from there, we use the road or line in which the robot will perform its task and follow the road. And then we also use the physics to create the mass and density about in the robot. And then in this line follower robot function, we created the transition and rotation of the robot, so it determines the speed and the velocity that robot will create to move from here to there. And then in here we created the background. There's like many background we can choose from, but we choose a certain background so that our robot can move. Then we also choose the color of the robot and the wheel of the robot. We try to differentiate the color so that the color of the robot and the track of the robot and the wheel of the robot are separated from each other. And yeah, that was our little effort to create this robot. And for this robot physical structure, we use some CFM, ERP, and physics templates from net that helped us create this robot. Thank you. That's all from me.
Hello, I'm Tanzimul Haq. My ID is 18101297. Now I'm going to talk about the distance sensors used in the robot. For adding distance sensor, we need to go to the base nodes and select distance sensor. After that, we have to rename it from here as there are three sensors. So we renamed it to IR right. Then we had to add a shape. We had to add a shape. From the geometric box, we need to select the sizes to 0.01. Then we have changed the color from appearance, PBR appearance, the base color to cyan, so that it is easy to visualize from here. Then we have set the metalness to 0. After that, we have changed the value of translation. For x it is 0.14, for y it is minus 0.0275, and for z it is 0.025, and the rotation is 0 for x and y and 1 for z, and we change the angle to minus 1.57. After doing this, we can easily copy those and rename them like IR left and IR mid. We just changed the IR mid rotation, IR mid's rotation to Z, which is 1, and the translation is for X it is 0.14, for Y it is 0.0275, and for Z it is 0.02. So that's all from my part. Now my other member will discuss the rest. Thank you.
Hello everyone, I am Shakhodda Samartha, ID 18101157. I am going to explain the coding part and simulation. First of all, a robot library is imported in the file. Then we define a max speed which is equals to 3.0. Then we initialize previous errors and other variables at 0. Then we initialize kp equals to 2.0, ki equals to 0.1, kd equals to 0.4. Then we get the time steps of the current world with time steps with time steps. Then we say initialize the motor list, which are front right wheel, rear right wheel, front left wheel, and rear left wheel. Then we initialize the sensor list, which are IR right, IR left, IR mid. Then we run two for loops, one for motor list, another one for sensor list. In the motor list we set the position of the motor slot infinity and set the velocity 0 0.0. And in the sensor list we enable the time steps of the sensor. Then we define the motor speed of the robot, and here we set the velocities of the motors. Then um, we run this while loop. If a robot's time step not equal to -1, then it will enter in this loop. And here if the right value is less than 900 and left value is greater than 900 and mid value is greater equal to 900, the error will be 2.5. And else if the right value is greater than 900 and left value is less than 900 and mid value is greater equal to 900, then the error equals to -2.5. Otherwise there will be no error. And this is the error counter, where we count the error. Initially there is no error. While loop implements, the error will get counted. Then we calculate the left speed, which is equals to max speed minus error balance, and the right speed, which is equal to max speed plus error balance. And as you can see, the robot is working fine. Thank you so much for watching the video.